Okay, perfect, yeah. So it's my great pleasure to introduce the last speaker of today, Hayato Saigo, who's been very active in this exploration of consciousness, categories in consciousness science, and yeah, it's a great pleasure you came all this way. Thank you very much, and looking forward to your talk.
Thank you very much. Thank you, Johannes and Sean, to give me this great opportunity to talk about the very, very important and difficult question. I wouldn't say that I can answer this question, but I propose possible naive answers from the mathematical viewpoint. What are states of consciousness? In this talk, text is mainly for the mathematicians. The figures is known for non-mathematicians, but this is only text which should be read by anyone. So the problem of what is mathematical counterpart of the state of consciousness is still unsolved. In this talk, we propose to consider state of consciousness as a linear functions on category algebras, we will introduce later, which is a non-commutative convolutional algebras constructed from categories. So precisely, we propose the following working hypothesis. Brain activities, or the new Andres new or something, and the IITs, the relationship between them forms a category, and the elements of category algebra, or the category aquarium, and the interrelationship between brain and its environment define the state on the category corresponding to the map from arrows to the expectation values of some time scale of intensity of them. The state on the category is the state of consciousness. We define many things. It may unite neuroscience and computing science and consciousness studies in terms of category and non-commutative probability. I am a mathematician and a mathematical physicist, and I tried to make a new alternative, new approach to the quantum field theory. The quantum field theory is a unification originated from the trial to unify the relativity theory and the quantum theory. And the relativity theory, from my perspective, should be generalized as some kind of category theory or higher category theory. And quantum theory can be generalized in mathematical terms, so-called non-commutative probability. So to unify them is a natural motivation for me for the quantum field theory. But at the same time, I'm long-term co-working with now here about consciousness studies. So I found that maybe this is also useful for the consciousness studies. Okay. So this is the table of contents. Then I'm an only person, maybe the old-fashioned introduction to the category. Of course, you can generalize it as higher category or process theory or something, but this is a very old-fashioned introduction to the category. The category is composed by the object, which is also represented by wires in the process theories, and this is box, but it is old-fashioned, and it is our system of arrows, processes, which can be composed as this. This is just a category, and this is object. Object is associated with identity arrow, and this identity arrow is this kind of thing, arrows. So you can identify the objects and identity arrows. So it is just all the process. So this is, do not read, no mathematicians and Bob, do not read this. Only mathematicians should read. This is just an excuse. Category, so functor is correspondence between categories which conserves structure of this kind of thing. And it is also called covariant functor. And contravariant functor is reversing this kind of orientation of the arrows, just think. And functor can be composite. So you can, and also you can define the very natural way, the identity functor, which corresponds to itself. So the functors make some categories, and the functors make the meta category of categories. And the involution is some kind of the functors, end functors, the functors from C to C. And yeah, the composition here. And mainly we are focused on the contravariant case, and especially the dagger category is a category with involution which preserves the identity. So F and F dagger is this kind of reversing, but it does not need to be the real inverse like a group theory or some group theory. This is just reversing the direction. Yeah. Okay. It is the end of the old-fashioned category. So the main thing of this talk is one concept which is important is category algebra. For mathematicians, it is just a generalization of the group algebra or groupoid algebra or something, or polynomial algebra, and or matrix algebra. But this is just algebra reflecting the structure of category. You know, this is old-fashioned picture of category. That this is arrows, these arrows, and identity arrows or something. Category algebra consists of the function from the arrows to the some numbers. Numbers here, we consider the set of numbers is called ring without negatives. Ring means plus, times, sums, and addition and multiplication, and no need for negatives in this talk. So just natural numbers, or real numbers, complex numbers, or if you need a tropical algebra or something, or 0, 1, a Boolean, or something, okay, the quantity or something. So the point is, this alpha is a function from C to R. That is f goes to alpha, f goes to some kind of numbers. Maybe sometimes this goes to g goes to 1 or something. So this is considered as a generalization of the correspondence of polynomials or something. So the coefficients to the arrow to these coefficients. So intuitively, this alpha can be considered as a polynomial of the arrows. That means this is arrow, this is arrow. Arrow as indeterminate, the letter x, y, z or something. So arrow can be considered just a letter, indeterminate in professional jargon. And you can consider linear combination, you can consider a product or something. But how to define the product? Idea is quite easy, but first I give you the definition of the convolution. That is, alpha is some kind of functions, or in other words, this kind of polynomials, or in other words, the weight or something. But this alpha prime and alpha can be defined a product of convolution. So if you know about something about convolution in some context, you can easily understand this. For C, alpha prime alpha, C is defined as a summation of alpha prime C prime alpha C prime, where C prime is composed. So factorization. This is C. All the factorization, the multiplied and the addition, like in a product of a convolution or something. Okay. So this is just for the important point. This is just text for the mathematicians. So what is Rig or the center? Because in this talk, you can consider Rig as a complex number or real numbers as you like. But my talk can be accommodate the non-commutative case, like operator algebra or something. So in that sense, in that case, we need to the notion of center, which is commutative algebra or the non-commutative algebra, which commute with all the something. But you can ignore if you like. Okay. So module over Rig is just a generalization of vector spaces. The rig is some kind of real number or complex number scalar, and the module is just a vector space or something. So you can generalize this. This is module over rig, and these are excuse for the mathematicians to accommodate the non-commutative case or something. And algebra over rig. Algebra is in general module and having multiplication. So algebra is for example, algebra over C, complex number, is a complex vector space, and at the same time it has a multiplication which is coherent with the scalar multiplication. This is called algebra in mathematics. So the category algebra is defined as follows. Let C be a category and R be a ring. So C may have the infinite numbers of objects or continuous number of objects, continuous number of arrows. It's do not mind it. It is general category, and the ring is general ring. The R-valued function alpha defined on C is said to be of finite propagation. No mathematicians just ignore it. It is just to make the definition well defined. And as a mathematician, I want to advertise this the merit of definition, but you can ignore it. And just for you can define this kind of thing, as I mentioned, and this so this set of finite function of the finite propagation becomes the algebra. And also it has a unit, multiplicative unit, which is correspond to all the identity arrows is coefficient 1, and the other arrows is coefficient 0. Okay. But if you feel this is too complicated, you can translate this in a very, very easy way. So as I said, the notion of indeterminate can be defined as follows. RC be a category algebra. RC is the set of these kind of alphas is called RC, but RC is a category algebra, and C is a category arrows in category. The function iota C, which belongs to the RC, defined as this kind of thing. So this is a function. The value is 1 if C equals C prime, and 0 otherwise. So this arrow C can be identified with a delta function. No mathematician does not understand. So, okay, this is coefficient 1, and the other arrows, all the other arrows is 0. So then, from the definition, you can derive this kind of very easy way to calculate things. So if you identify this and this, it does mean that you can make product of arrows, multiplication of arrows. If it is composable, it is the composition itself, and if it does not composable, this kind, then you can multiply to 0. Yeah, this kind of thing. So in this case, undergraduate can calculate the category algebras. So just do the distributive law, like junior high school or something, and then consider this kind of terms based on this very easy way. So the arrow as indeterminates and category algebra of linear combination of arrows. Yeah. So just a few words, and you can consider the category algebra also as a matrices, a generalization matrix algebra. Actually, if you consider the indiscrete category, which is the special kind of category, that is there is one and only one arrow between any two objects. This is called indiscrete category. In this case, the category algebra is in this case 3 objects in discrete category. Then it is just 3 by 3 matrix algebra. So it is a generalization matrix algebra. So what kind of generalization? So in linear algebra, you can say that 1, 2 components or 3, 2 components, but the parameterized by objects in category C. So C prime C components is a form that this kind of thing. From the definition you can get. And this is by using the identification of C and iota C, it is just a linear combination of the alphas. So this alpha is represented as this kind of generalized matrix typed, whose components are typed by pair of objects. So this component is some kind of polynomial of alphas. Only the diagonal components have the higher order of polynomials, but it is just the representation, and the product as convolution can be considered as a matrix multiplication. It is a very easy exercise, or if you're interested, you can read my paper. Okay. Then the important thing is involution structure. The merit of complex numbers in quantum theory is a very good question, and some categories and process theorists maybe within here can explain why complex number is important. But one very practical point is it is some kind of for the spectral analysis of something. So to do such a thing, we need a complex conjugate structure to do some positivity, to represent some kind of notion of positivity. We need such kind of complex conjugate line or unit conjugate line thing. So this is called involution. This is just like here. But interestingly, it is not so new, but known, but I generalize that. But category algebra becomes algebra with involution if the C has such an involution in category sense. Also, especially the Dagger category. In Dagger category case, it becomes a star algebra, which is just a generalization of complex number or matrix algebra or something, which is also important in mathematical physics or quantum information. So the most important notion in this talk is states on categories. I think this is my original because category algebra, especially the special kind of category algebra, is very much studied. But I am non-commutative probabilist. So non-commutative probability theory is just a study of the pair of algebra and states. By starting from algebra and states, if you want, you can construct a Hilbert space and a bounded linear mapping between them or something. So you can construct everything in the usual quantum mechanics text can be reconstruct from this. So states, what is a state in this term, in this context? So the conceptual notion of state is this kind of thing. The system is interacted with environment. A kind of intrinsic structure of system can be represented as algebra. For example, electron or photon or something in different contexts behave like very different, but it has spin or something. It's momentum or something. This common feature or intrinsic feature is represented by the notion of algebra. And the state is, conceptually speaking, represent the interrelationship between the system and the environment. So if, important conceptually important point is this environment itself is a system. So system and the space environment is not necessarily complement set of the system in the world. You can choose another environment. You can consider the more larger environment or something. Alice may be environment, and Bob may be environment, and Alice and Bob also can be environment. So the identical system can have the different state. So for selecting this interrelationship, you can reconstruct another Hilbert space. So this point is very important in the quantum field, the study of quantum field theory. But I omit this story, but just conceptually. So my view, which is very deeply affected by my ex-supervisor Izumi Ojima, who is a specialist in quantum field theory, but the state is some kind of interface between the system and the environment. So mathematically, state is the mapping from algebra to the some number system, really. That is conceptually considered the generalization of expectation function, which is this algebra, for example, the observable algebra in quantum theory. So momentum or energy or something. Then the situation is given. Then the expectation of the moment, the expectation of position or something is determined. So this correspondence satisfies the linearity because the expectation is linear and has a positivity because the probability is positive, and the unit be mapped to 1 because the probability is 1.
I think we have 5 minutes excluding questions.
Okay. So this is non-commutative probability. So you can consider the state on category algebra. Naturally, I omit them. So in that sense, and state is this theorem says that state can be correspond to the 1-to-1 to the this is a figure. The state is category the map from category algebra to the. It is 1-to-1 correspondence if the object is at least a finite number of objects. Arrows can be infinite. But the positive function, the positive means if you consider some kind of matrix, this time this is arrow, C, C prime, and C prime component has given by this, then this is a positive semi-definite. So to define the state on category algebra is equivalent to define some kind of function, positive function on category. This positive semi-definite function is also called the kernel in the machine learning world, such kind of field. So state is just such a thing. So the working hypothesis I will propose is Gray activity or from the, of course this is how can we define is the most important point, but if you are given some kind of Gray, this is neural activity and causal relationship or more coarse grained thing, but you can consider the algebra whose elements are discrete function. That means intuitionally, not single this relationship, but multiple pattern of this causal relationship should be correspond to the Fourier. And also the state of consciousness as a state on C, or it is one-to-one correspondent to the function on C satisfying the positivity. So this is just a naive hypothesis, but it is natural to think this positive weighting on the arrows is some kind of corresponds to the expectation values of the intensity of this, for example, for the causal relation or something. So for some time scale, but this I think this kind of characteristic time scale is very important in the consciousness science. And my proposal is a state on the category is a state of consciousness. But I have a very interesting proof of that, but I don't have the room.
Amazing. Okay, so we have 5 minutes for questions. Who has questions? Yeah, there's one.
Hi. So I didn't understand what is this category of brain activities exactly, like how it's made, what are the object and materials?
Thank you very much. This is not defined, but not defined because there is many possibilities. But in my mind, by coarse graining, by the time scale and the corresponding the space time scale, you can make a coarse-grained version of the brain, and this brain activity and this causal relationship. The brain activity should be correspond to the objects, and the causal relationship between them is the arrow.
So brain activity is like a time series of observations of some like
more naive. For example, the state change. I omit the state change or dynamics of brain, but the state at a given time is a given time is this given time, but it have to have the timeless because of the like I think now should say something about that, but a kind of time scale should be so. In that same time scale, this causes this or something. So this is in my mind.
So now is first, and then Ina and Toby and Lucas.
My comment is kind of a question or request to maybe Sean or Bob actually. Is it possible to consider this category algebra and also states on the category algebra in a process theory kind of framework?
No.
And have you thought about that?
Yes. Actually, I think this is bidirectional. The short answer is bidirectional. You can consider. I only talk about one category theoretic usual aspects, but monoidal structure give the more richer structure on algebra. So category from algebra. And the reverse direction is that if you give some category, not necessarily the monoidal categories, but the Nagahama category, then you can construct monoidal category from category algebra by choosing, for example, C1, C2, C3, or C3, C prime, C4, C5. Then you have the partial matrix, the partial matrix algebra. So which corresponds to the box, and the value is collection of objects. So you can make the process theory, a special kind of process theory from this. So I think it's bi-directional.
Thank you very much. Next question, Ina?
Yeah, I just wanted to dig a little deeper into your previous answer. You mentioned that you pulse brain activity. I'm curious about what aspects you prioritize.
Sorry?
I'm curious about what aspects you prioritize when you engage in coarse graining.
Yeah. For example, I do not say that the coarse grain thing is more, how to say, far from reality. But I do say this coarse graining is also physical. For example, entropy. In general, is ultimate microscopic level. It vanishes, but the entropy is very physical thing. So in that sense, that there is such a reality which only can be grasped by the macroscope.
So next one is Lucas, then Toby, and then you. Lucas, you're first.
I also wanted to understand better your previous answer on this object, so also related to this question. So, did I understand correctly that an object is basically the current state or like the state of all the neurons in the brain at a certain moment in time, or and what is that state? Is that just whether they fire or not, or do you resolve more structure with what she said? Because neurons have actually quite complicated structure. So yes.
Yeah, thank you very much. As I mentioned in the question to the Johannes, I also say that the strength of the category theory is the richness of the construction category. So there is many can be considered many things to be categories. I think the brain activity or information structure is also some category, and this conscious experience also have such a categorical structure. For example, if you consider this phi itself can be considered as an object in the so-called slice category, in the category of algebra and CP maps, completely positive maps. Then you can consider state as also object. So maybe our conscious experience is based on the not only this state, but there is many candidates of possible states and its relation by the completely positive maps or something. So maybe this should be the kind of level of consciousness. Maybe I now also have it. So the answer is there is many aspects which can be connected to the categories, and the category theory I think should be very good at unite these different aspects of the category. So many level, multi-level category can be connected by the categorical construction.
Toby, and then we have you, and then it's
Yeah, I mean, mine's not really a question, it's just a remark that what you were saying about brain activity sounds a lot like what Andre asked.
Yes. I forgot to say that, but yes.
wonderful. Yeah, go ahead, please.
In quantum field theory, the self-adjoint element of the algebra corresponds to an observable. And the observable can be observed to have the each instance of the observation gives you the one outcome of measurement. Usually it's a real value. And in your formulation, the self-adjoint operator, self-adjoint element of the algebra, does it correspond to observable, and what is the observation of this observable, and do you assume each instance of the observation gives you one instance of outcome, and your state gives the probability distribution of that outcome?
Yes. If you start from the category, the element like category algebra is just like usual conjugate like thing, and for the point of positivity, so how to say it? If there is many arrows like this, but if dagger, so if dagger is some kind of the endomorphism from here to here. The interesting thing is, at least for finite number of objects, this probability distribution is an element of category algebra or state of supported only on objects, not. There is an arrow, but this does not have the non-zero value. Only this has a non-zero value. So this is a probability distribution. So I think, as you pointed out, in that case, the set of objects is kind of outcomes, and there is more than outcomes. So relationship between outcomes.
So your state determine not only expectation value but also determine the probability distribution in that case.
In that case, yes.
Thank you.
Okay, that's wonderful. So let's a big round of applause.